Okay, so welcome back to ETCS Bytes Back, and today we're going to have a look at System National, or Mode SN. In Level NTC, which is National Train Control, the normal operating mode is SN. As you all know already, I think, Level NTC, National Train Control, which was previously known as Level STM for Specific Transmission Module, allows for the operation of trains using the existing Class B protection system. That could be our national ATP system, it could be a train protection warning system in the UK, or any other system. In Level NTC, it is expected that the Class B system will provide most of the supervision, and ETCS does very little. We should note that in Level NTC, Shunt Mode SH is also available. So what does the driver get to see? Well, because the Class B system is in charge, the ETCS just displays a simple speedometer. There is an option for extra information which has been passed from the Class B system via the STM, the Specific Transmission Module, to the ETCS to also be included, such as a limit speed or target speed. The driver is expected to observe the signals, obey verbal instructions, or the information provided from the Class B system. So what is supervised and what is available in SN? Well, the only thing that is really supervised is the STM maximum speed. So the Class B system can, if it is so configured, provide a maximum speed to the ETCS, and that will become the ceiling speed for the train. However, because operating in NTC could be on the way to an area of ETCS, or there could be other things the ETCS system needs to know about, then some of the functions of ETCS are active. And these include to read and check each Belize group that the train passes over, to check the messages are valid, and if necessary, generate an error. The error is because the message could be of a safety critical nature, and not reading that message could lead to a hazard. One of the things the Belize messages may instruct the train to do is to connect to the RBC over the radio connection. And once that is connected, it is monitored in a similar way to when ETCS is active. If the train is going to enter an ETCS area, it is going to need to report its location. So it is monitoring the Belize groups and determining which ones are a compliant LRBG and maintaining the position relative to each of those Belize groups. Depending on the status of the train and whether there's a radio session, these positions may be reported. Of course, one of the problems with Belize's is that they can be hidden if there is a big metal mass. Big metal mass is a large metallic element between the rails, which causes the Belize reader on the train to generate an error. Facilities exist to tell the train that it is approaching an area where this may occur, and so to ignore those errors. And lastly, managing virtual Belize covers. Sometimes a Belize group will have information which is not yet applicable to the train, and a virtual Belize cover can be used to hide the information even though it is read. So, what's different about having a train without ETCS and having one with ETCS but operating in SN? Well, very little. Effectively, when the train is in Level NTC, the ETCS sits completely in the background and does nothing. The driver can move the train forwards and backwards, and supervision at all times is only provided by the active Class B systems. Now, whilst ETCS only enables one STM to be active, it is not uncommon on some railways for multiple Class B systems to be active at the same time. The real change is that the driver needs to go through the ETCS start of mission process and enter train data. So that is an introduction to SN, the mode associated with Level NTC.